Hey everybody, Mr. Holmes here. I wanted to show you a quick demo with regard to acids and bases, and this involves interacting spheres of the Earth, the atmosphere, and the hydrosphere. And you may have been told by parents, don't drink so much soda, you're going to rot your teeth out. And yes, there could be a lot of sugar in soda, but there's another issue going on. And so I'm going to kind of explain what's happening there. I will also make reference to the pH scale. So a neutral solution as well as a weak acid to a strong acid, and then go in the other direction from a weak base to a strong base. So I'll insert that into the video in a little bit. But one thing I'm working with here is bromethymol blue, and this is an indicator that will stay blue. And I'm just gonna, let's see if we can get a little bit going on here. A couple drops. And I'll put a couple of drops here as a control, as a standard to compare it to. Let me go get a stirring rod and I'll be right back. Okay, so one of the things, I went ahead and I swirled that bromethymol blue into that water. This beaker on the left, I'm just going to leave as is. This is just straight water. It's a pH of 7, and it's got the bromethymol blue. This is the same here, but this is the one I'm going to mess with a little bit. So one of the things I wanted to tell you, if you look at the ingredients carefully that we're going to be adding to this, I've got sodium hydroxide and hydrochloric acid. So we have an Na, which is your sodium, and an OH, oxygen and a hydrogen stuck together. And then also we've got hydrogen and chlorine. And if you kind of take a look at both of these, notice we have an H and an OH. So if we were to mix these together, you'd get H2, you'd have two hydrogens and an O, so that's water. And then the sodium and the chlorine would turn into sodium chloride. You might know that as table salt. Now these are different strengths. This is a whole lot stronger. This is 6 molar and this is a 1 molar solution. So but what I wanted to show you is that this bromethymol blue is going to stay blue unless there's a presence of an acid. So I'm going to take this hydrochloric acid and we'll add a drop and see what happens. Stir it around a little bit and whoop. All right, so we have an acid in there now. So that's where that hydrogen comes into play a little bit. I can neutralize this by adding a base. Okay, and this might take a couple of drops because it's not as strong of a base, or it might turn blue and then we getting there almost. Come on, 3 drops. And is it gonna stay? No. 4 drops. Let's do 5 drops. Is it? Okay, let's do a 6th. Okay, so that is what's happening there. So we've returned it back to a pH of 7, or maybe it's slightly basic, but I could continue to add a drop of acid. It'll turn yellow, and then I can get it back to blue by adding something that is basic, that has the OH minus on it. So, so those are sort of the key ingredients in this color changing thing, is when these things break together, break apart, we've got an H plus and an OH minus, and when those are going to come together, those will produce water, and then the Na plus and the Cl minus are going to make table salt. So all right, so that's that situation. That still is, we're almost there. Okay, 2 more drops of that will make that a base. Now, cool, let's get into the next step here. Okay, so I may have mentioned before that, in the carbon cycle, part of being able to burn sugar and release the energy stored in sugar is by taking in oxygen. And so as I am breathing in, oxygen's going in, but guess what? Cellular respiration, or the burning of said sugar, produces carbon dioxide and water. So the other thing, the other reason why we have lungs is because we got to get rid of that carbon dioxide. Because the carbon dioxide in the presence of water becomes carbonic acid. And so when your parents or grandparents or aunts and uncles or whoever was yelling at you for not drinking or for drinking too much soda, it's not just the sugar content, it's the carbon dioxide. The bubbliness of that water is actually, it's acidic, and so the acid might be an issue for your teeth. So what I'm going to do is I'm going to flip this thing around, and I'm going to be exhaling into this aquarium tube, and it's got an aquarium air stone, and I'm going to see what happens when I am blowing carbon dioxide into water. Okay, so I'm going to take a deep breath in a few seconds. We're going to throw this little, let me get the stirring rod out of here. I just yanked this out of the aquarium, so I apologize, fish. We'll get you back to normal at some point soon. But anyway, so here's my air stone, and I'm going to go ahead and breathe into this, and let's just see what's happening. This is carbon dioxide that is exiting my lungs when I exhale. Whew, holy moly, I'm gonna pass out here. Maybe we'll lose the air stone. Let me try a little bit more, but this is a very small diameter air hose, and so it's really kind of frustrating, giving me a lot of resistance. Okay, forget that. Let me get rid of this air stone. All right, there we go. Woohoo! No, I'm not going to fall over my chair. Okay, it's going to be a little bit messy, but we're going there. Okay, hang tight. Almost there. Whew. Oh, well, there we are, huh? Okay. Whew. Holy moly. I need a larger diameter hose here. Let me just now switch up to these smaller air bubbles, which will have a lot more surface area to interact with the water. Okay, that's about it for me. I am tired. Probably need to go get some more exercise or something. Okay, so as you noticed, as I was exhaling into the water with my carbon dioxide, this was CO2 going into that water, and notice that it changed the pH and it became more acidic. And so this is actually an acidic solution here. And that is kind of a global issue going on now. So I would like you to think about increasing carbon dioxide in the atmosphere and how that's interacting with the oceans. And this is a process called ocean acidification. Now, I'm not going to suggest that we go around pouring like bleach or drain cleaner into the oceans, because that's pretty nasty. But notice that with the addition of a base, I should be able to bring it back. Okay, and then if I exhale again, I will be able to bring that back to an acid. Okay, so for my last little trick, I wanted to introduce one more item to this. So I've got my sodium hydroxide, the hydrochloric acid, and the indicator, bromethymol blue. And what I would like to do then is show you what happens when I just take regular classroom air and breathe that into this. So we have just the ratio of oxygen to carbon dioxide is going to be a lot more oxygen that's coming in here. So I'm going to hook it up to this aquarium air pump, and I'm going to do a time lapse on this because this one is going to take a little while. And there goes my automatic light. So let's go ahead and plug that in and get that started. Okay, so that took about 7 minutes, but it looks like we are back to neutral, pretty close to it. So the reason why that took so long, and I did a hyperlapse recording, is because all those jiggly, wiggly, dancing bubbles of air coming into this it took a little while to physically knock the carbon dioxide bubbles, out and neutralize any of the acids that were in there. But just by using regular air coming from the classroom, this is evidence that there is more oxygen in the air than carbon dioxide. If I go and shove this down my lungs and exhale into it, I can change it back into acid. It'll turn yellow, and that is proof that I've got way more carbon dioxide coming out of my lungs than is going into my lungs. Technically, that's little evidence that I am alive because I am burning sugar and taking in oxygen and then burning that stuff, getting a little energy to live, and now I have to get rid of my waste products, and that is carbon dioxide and water.